Hi dear student, this is Sanal from Heal Bodhi classes. Welcome back to AS Level CAIE Physics 9702 series. So in the last module, we have studied physical quantities and measurements. As I told you, that is the base of physics. So I strongly suggest that you learn that topic properly. And if the concept in module 1, that is physical quantities and measurement, is strong, means you can learn the remaining topics easily. Now we are moving to the module 2 of AS Level CAE 9702 series. In module 2, we are going to discuss kinematics. Kinematics means what? Kine means motion, matics means represents mathematics. So what is kinematics? Kinematics is mathematics of motion. In this module, we will learn about kinematics variables. So what are the kinematic variables? First one, position. Second, distance. Third, displacement. Fourth one, speed, velocity, acceleration. First, we will learn and understand the concept of position, distance, displacement, speed, velocity, and acceleration. These variables are the basic variables required to study motion. So that is kinematics, right? So after that, after studying all these variables, we will learn uniform and non-uniform motion, okay? Uniform and non-uniform motion. Then connecting these variables, we will learn the equations of motion. So what equation we will learn? In this session, we will learn how and when to apply. Most of the confusion will be from choosing the equation. So I will give a proper technique to identify the required equation for a question. Okay. So after SWOT equation, we will learn graphs. Analysis. Okay. Full analysis. Okay. How to interpret a graph. How you can extract the information from a graph. Everything I will explain in the session. That is the most important session because most of the student will lose mark from graph questions. Okay. First, I will tell you how to analyze the graph. The step-by-step method I will explain in that session. After graphs, this I will give you general idea about the graph interpretation. Then we will apply those concepts to study displacement time graph and the velocity time graph. Okay. Then finally, we will do projectile motion. Then topical past paper questions. So you need to remember the order of the content module wise because I have prepared this in orders. I said you can remember it. Okay. When you study it, you will, if you remember the order, it is easy to recall it. Okay. What first we will learn? The kinematic variables. What are they? Position, distance, displacement, speed, velocity, and acceleration. These things we will learn first. Then uniform motion and non-uniform motion. What is the difference? Then equations of motion. So what equation? How, when, and which equation should be applied in a given question? How to identify that? Then we will study how to interpret graph. Generally, which all things, which all information you can extract from a given graph. Then we will apply those to study displacement time graph and velocity time graph. Then up to this point, we will learn only one-dimensional motion. That motion will be in a straight line. After that, we will learn two-dimensional motion, which is projectile motion. Okay. With that, we can finish the concept explanation classes and practice session. Then finally, we will have past paper practice P1 and P2. Then this module will be finished. Okay, clear? So first we will start with the first kinematic variable, which is position. So position. I will ask you one simple question. If I am asking you, like, where is your pen? You can say the pen is in my hand, or you can say the pen is in your box. When I ask where is the box is kept in my bag. Where is the bag? It is in my shelf. So like that, you can describe the position of objects, right? So to describe the position of an object, you require something. What is that? Let me explain. First one, in this plain paper, if I am asking you to describe the position of this point, or this is an object, or this is a dot, describe it. How can you describe? You can't describe, right? Why? For describe the position, you require a reference point. If I am giving you this reference, that is xy plane. If I am asking you to describe the position of the point with respect to this x and y plane, then you can say, you can describe it, it is x distance, this is y distance, right? So you can describe the coordinate as x and y. So this is suppose 5 and this is 2. Then what happens? You can say that if this point is 5 units away from the origin along x-axis and 2 units away from the origin along y-axis, right? So such that you can describe the position. Understood? So describing the position of an object or a particle, you require a reference point. So the motion, this is the first variable you are learning, right? So in motion, in kinematics, when you study the motion, everything is with respect to a position, a reference point only you can describe. Even if it is position, distance, displacement, everything is described with respect to a position. Is it clear? Okay, position, the concept, is it clear or not? Yes. Then we will move to the second variable, 2. Distance. Distance, d, usually d, we will use distance, the simple. It is described as the total length of the path covered by an object. If you are considering this point, is it in motion? No. With respect to time, the position is not changing. That means the object is at rest or the particle is at rest. How can you describe motion? Motion means what? If a particle changes its position, if a particle changes its position with respect to time, then the particle is said to be in motion. You understood? What is motion? If a particle changes its position with respect to time, that means initially t is equal to 0, the position is this one. T is equal to 2 seconds. If the position is changed to this point, that means with respect to time, it is moving, it is having a motion. Understood? Okay. Distance means the actual length of the path covered by an object. Okay, so the actual length of the path covered by an object. You don't need to specify its direction. In any direction you can do it. Okay, so If direction is not there, only magnitude is there, what type of quantity is that? It is a scalar quantity. So the distance is scalar quantity. Understood? So one more important point is there. You check this one. If an object is moving from A to B, then this object is moving from B to A. Okay. Then what is the distance? Distance, suppose this is d, you take same distance it has covered, the distance will be 2 times d. So it can't be 0. Okay. It can't be 0. So distance can't be 0. These are the properties. Okay. Distance can't be 0. And one more thing is that since there is no direction, you don't need to take the sign towards right positive, towards left negative. You don't need to take any sign for that. So it will get added up only. So it can't be negative also. Distance can't be negative. Third point you need to remember, it won't consider the direction. Okay. These are the points you need to remember related to the variable, kinematic variable distance. Clear? This third one, displacement. Displacement, usually we will use S as a simple displacement. So what is displacement? Displacement is the shortest length from initial position to final position. The shortest length of the path from initial to final position. So you are mentioning initial to final position means you are mentioning the direction. So direction is important here. So what is that? Then it is called a vector quantity, right? So displacement is a vector quantity. Displacement is a vector quantity. So you can write the description as what is that? The shortest length of the path covered by an object. From initial position to final position. So from initial to final position, you need to remember this one, initial position to final position. This will specify the direction. Okay. For example, an object is traveling from A to B and it is moving in this direction and reaching this point. So this is the direction of motion. It is reaching the point. So what is this green line? The length of this green line will be the distance. This is distance. It can be in any direction, okay? And what will be the displacement? Displacement is the shortest distance. That means it will be a straight line, right? Straight line is always shortest distance. So this is red. This is a vector quantity and this is displacement. So distance and displacement, is it clear? Displacement is vector quantity and distance is scalar quantity. So what are the points you need to remember here? First one, displacement is a vector quantity. Suppose from A to B, it is moving straight line only. Then what happened? Distance and displacement are equal, right? If you change the direction, if this was initial position, this was final position, you need to draw the arrow in opposite direction. So it can be negative also, right? So 2 points you can write: displacement can be negative or positive. Displacement is always less than or equal to the distance. Correct or not? It can't be negative or positive. So you can say that displacement S is always less than or equal to D. It can be equal or less than the distance, right? Clear? I will give you one simple example to remember distance and displacement. So you consider a cube with the side A. An insect is moving through its side. Look at that. From you take this position is A. It is moving here. Then look at this one. It is moving here. It has reached this point B. Then it is moving towards back. It's C. Then it is moving here to here. That means A, B, C, D. So an insect is moving from A to B, B to C, then to top. Okay. You need to find out the distance and displacement. Displacement and distance you need to find out. First you check from A to B. A to B, then this side is A, this side is A. All sides are equal because it's a cube. Total distance, which is equal to A plus A plus A, which is equal to 3 times A. Correct? That is the distance traveled. When you try to find out the displacement, what is the displacement definition? It is the shortest distance from initial to final position, right? So A, B, C, D. When you check the final position is D, initial position is A, you draw a straight line from A to D. So what is this? This is the body diagonal. It is going through the diagonal of the body, right? Body diagonal of the cube. You need to find out that. How can you find out? So you consider a triangle. Triangle ACD, right? You require this hypotenuse of this triangle. So what is this base side? Look at this one. This is a right angle triangle, right? Including the body diagonal, right? Which is equal to ACD. This CD, you know that it's A, and AC is the diagonal of the base. So how can you find out the diagonal of a cube square? This is A. This is A means what is the root is? This is A square plus A square. Root of A square plus A square. So that term will be 2A square, right? Root of 2A square, which is root 2 times A. Correct? So this side is what? Root 2 times A. Then you can use the Pythagoras theorem to find out AD. So AD will be the displacement, which is equal to root of A square plus this AC side is what? Root 2 times A, the whole square. So which is equal to root of A square plus 2A square, which is equal to root of 3A square. So what is the displacement? Root 3 times A. Root 3 times A. This is the answer. With this example, you can clearly differentiate what is distance and the displacement. Correct? Understood? So what we have learned today? We have learned the first part, the kinematic variables. What are they? The position, distance, displacement, velocity, speed, acceleration, right? So out of that, what we have learned? Position, the concept of position, distance, and the displacement. So this is the part 1 of module. We covered distance and displacement now. So you just learn up to this point. In the next video, we will discuss about velocity and speed. See you in the next video, module 2 part 2. This is Sanal from Heal Bodhi classes. Bye.